So on problem 2, we'll continue. We'll take the remainder that we may or may not get on the problem and continue to divide. And a lot of times people will call this carry it out, okay? I'm saying let's add the trailing zeros so we can end up with a perfect problem with no remainder, okay? And Halen, you weren't here, but we only did one problem, so I think you're going to be okay, all right? So let's set up 2 6/10 divided by 4 on the standard algorithm. Who remembers, so go ahead and write that down. Who remembers why I just get to write my decimal straight up? Sadie?
There's going to be the same amount.
You're right. You're going to end up with the same place value that you started with. Do you remember why you end up with the same place value? We're dividing by a whole number, okay? A whole number. So let's get this put on the place value chart. 2 1s and 6 tenths. Yes, you can. I think that's pretty much a given now. You don't have to ask permission. It's just easier to make dots with highlighters. I noticed that my divisor is larger than my dividend today. But remember, we put the number with the most digits in the doghouse. Okay, so 2 divided into 4 equal groups. Can I do it? So what do I need to do? Regroup, and look how we're making our group of 10 today. This is 1 group of 10, this is 2 groups of 10. What does this look like on the standard algorithm, Maite? What will I write above the 2?
0.
Okay. Do I write anything down below? No. This gives me 26 tenths. Is that what I have on my standard algorithm?
Yes.
26 tenths, okay? I'm going to go slow. I want you to try and stay with me, all right? So now, I noticed today we're working on the multiples of 4 quite often. So I'm going to write those down. Tell me if I made any mistakes. And I don't even actually need 40 because I'm not going to write a 10 at the top of my doghouse. The largest number I would write is what?
9.
A 9. Very good. Okay, so these are the multiples of 4. I'm going to use those to help me divide. Okay? This is one strategy. If you don't need it, just be kind to the rest of us while we work through it. Okay, so now I have 26 divided into 4 equal groups. And which one of these multiples?
24.
Now I'm going to ask a question. 4 times something equals 24. What is it? 4 times 6 equals 24. On the place value chart, I need to put 6 in each box. Okay, Hayden, are you writing? Don't forget to write. So if I started with 26 here, how many do I have left over? 2. 6 minus 4 is 2. So that's how far I am.
Me too.
Okay, so these 2 that I'm going to regroup will become 20 hundredths. How do I make them be 20 hundredths on the standard algorithm, Daniel? I mean, it's 20 hundredths here, but right here I only have 2 hundredths. So how do I turn it into 20? On the standard algorithm, do you remember? You add a 0 at the end. Now, was there already a 0 here? So it's no big deal just to write it. Right. They're called trailing zeros, and they're there. We just don't always write them. So now does my standard algorithm match my place value chart? Yes, it does. I have 20 on both of them. What multiple will I use over here? Now don't say it. I'm going to ask Fernando. 4 times something equals 20.
5.
Good. So the 5 is going to go at the top, and it's also going to go in each group. Let's do another one. I'll walk you through another one. We'll see how you're doing, okay? Right, take a look at problem 3. It's a little different. What's different that you see about this problem? I still have multiples of 4. Let me write those real quick. It goes up to the tens. There's no decimal. Well, there is a decimal, but it's not, this is a whole number, isn't it?
Yeah.
Okay, so 17 divided by 4. So the divisor is still 4. We're practicing our 4s today. So here's what I want you to do. 1 10 and 7 ones. Or would you rather start with 17 ones? Why do you say 17 ones, Tucker? I agree with you.
Because there's no decimal between the 1 and the 7.
Well, true, but I mean, there's no decimal between the 10s and the 1s. Why would you say start with 17 ones instead of 1 10 and 7 ones? My take?
Because you still can't divide 4.
You can't divide 1 into 4 equal groups anyway, can you? So you could do that. You could write the 1 there and then regroup, or you could just start with 17 ones. What do you think? 17 ones. So that means I'm not dividing the 1 by anything. So I'm skipping it. I moved it over from the very beginning. If it helps you to know this, you can write a 0 there. But I think you're to the point where you can chunk that 17. Now here's what I want to ask you right now before we go any further. Is 17 divisible by 4? No. 17 is actually what kind of number? Do you remember? The only factors are 1 and 17.
Not a prime.
Starts with a P. Prime number. So I know this is not going to divide evenly. So you know what I'm going to do before I ever start? I'm going to put my decimal on there. I know I'm going to need to add zeros because I know that 17 is not divisible by 4. So why did I put my decimal there? Tucker? Is that where it usually is anyway? At the end of a number?
Yes.
Yes. And what are these digits over here that we don't write down, Tucker? Zeros, aren't they? So I'm not changing the value of anything by writing the decimal down. Okay, so which multiple, and I want you to help me here, which multiple over here is closest to 17 without going over?
16.
Okay, and I want you to answer me.
16.
No, Fernando, 4 times what equals 16?
4.
Okay, so I put my 4 at the top. And how many will be in each group?
4.
Good. And once I cross everything off, all 16, how many will I have left? 1. So on the standard algorithm, it looks like that. Now remember, I was thinking ahead, wasn't I?
Yes.
I knew 17 was a prime number. I knew I had to add my decimal. So now I'm ready to do what? Add my 0. When I add my 0, how many tenths will I end up having? 10 tenths. Now, what? Don't shout this out, but which one of these multiples is closest to 10 without going over?
8.
I said don't shout it out. Okay. How about you, Julian? 4 times something equals 8. What is it?
2.
2. So, how many will be in each group here? 2. How many do I have left over? Remember, we're showing this is 10. We're showing 10 with a line today. The easier way. Okay? So how many did I have left over?
2.
So to show that regrouping, I'm just going to do this. Quite simple. Much easier than dots. So how many hundredths do I have?
2.
No, I don't. 10, 20. How many?
20.
20. How do I show 20 hundredths on my standard algorithm?
0 to the end.
Okay, which multiple, Lainey, am I going to use over here that's closest to 20 without going over? 4 times what equals 20? 5. So 4 times 5 equals 20. And do I have any left over?
No.
Got to cross that off. Okay, Hayden, what's your question? Yes. Okay, we're going to try another one. Are you doing okay? Are you at a 3 or a 4, 0 to 5? What do you think?
5.
A 5?
Maybe
A 3 or a 4? I feel like once you do it independently, it's going to get a little confusing. So let's move on. Oh, we don't have 4 for a multiple anymore. We have 8. Now, count by 8s for me.
8, 16.
Wait. Raise your hand if you were in Mrs. Howie's class. Was there a song for this one?
Yeah.
Sing it.
8, 16, 24, 32, 40, 48, 56.
Okay, I'm gonna stop before I get to 80. Because we don't need 8 times 10, do we?
No.
All right. So why'd I write those right there? Have I lost my mind?
No.
Just move them over to here. They're there if we need them, okay? All right, 22 divided by 8. How would you set this problem up from the very beginning? Channing, what would you do?
You would do well, since you can't do 2 into 8, you go ahead and just move it all to the ones.
Okay, so we're going to have 22 ones, aren't we? Looks like that. And if it helps you to know that you skipped the tens place, you can write a 0 in the tens place right here. But I'm just okay with chunking that 22. Are you? You just have to know that you're going to write your answer
Your decimal.
above the 20. Why do I need a decimal?
I
You're right.
don't know. Because there's gonna be more.
There's going to be more.
More numbers.
You're going to need more numbers because 8 what, Tucker? Is 22 divisible by 8?
No.
No. Okay. So let's take a look at this and we're going to go slow. So Channing told us how to set it up. We've got our standard algorithm ready for more numbers because we know it's not going to divide evenly. And who should I ask? Daniel, which one of these multiples of 8 is closest to 22 without going over?
16.
16. 8 times what, Fernando, is 16?
2.
8 times 2. So I have to write that 2 above the ones place, because that's where we moved everything. Okay, get it written. So how many will be in each group here?
2.
2. And he said 2 times 8 equals 16. Hannah? What is 22 minus 16? 12 minus 6. 6. Okay? So, as I'm getting ready to regroup, how many will I have to move over? Regroup.
10.
6 of them! So here's how I'm going to show it. These are all used up, but I have 6 left over. And that's just easier than the dots, isn't it?
Yeah.
So I've got 60 tenths. Make sure you write that down. Notice I'm writing a little smaller now because it's getting crowded. Okay, how do I make my standard algorithm look like 60 tenths? You're really? I add a 0 and bring it down. So now I have 60 tenths. So back to my multiples of 6. Daniela, which one of these multiples of 6 is closest to 60 without going over? 56. So 8 times blank equals 56. 7. Awesome. So how many will be in each box?
7.
Blair, get caught up with me. $56 is a lot. A lot of dots. Okay, so this is where you are. And she just told us 8 times 7 is 56. 60 minus 56 is where we are. All right, who have I not picked on? Kimberly. What's 60 minus 56? Now I could regroup if I want, but you don't have to. You can just look at 60 minus 56. What's the answer? 10 minus 6?
4.
So when I cross off, how many will I have to regroup?
4.
4. Julian, how do I show 40 hundredths on my standard algorithm?
Put a 0 and bring it down.
Write a 0 and bring it down. Which multiple of 8 is closest to 40 without going over? Just say it. 40.
4.
So now I have to think of this. Answer to this question, Tucker. 8 times what equals 40?
5.
Good. And if it helps you, think of it like that. He says 5. Do you agree? Yes. Oh my, that's a small eraser. Okay, here, get that bigger. Okay, I shouldn't hear your markers, Blair. And so to finish this off, with no remainders, we're done. Okay? Let's take a look at one of these without the place value chart. Let's see how we do on that. Did you put your 5 in each box? Okay, let's move over to the next problem. What problem is it? 5? Okay.
Yes.
So what is the divisor?
7.
No, it isn't.
So it's 4.
4. You divide by the divisor, right? That has to go on the outside of the doghouse. That's the first thing you have to get straight. So what would I skip count by to solve this problem?
4.
4s. I'm getting pretty good at those 4s. Where can I stop?
38.
You're close. 36. Good. Okay. So, should I pop my decimal up? I think so. Okay. 4. Which multiple of 4 is closest to 7 without going over? 4. 4 times something equals 4. And remember, you're just going to ignore your decimal for right now. You are not going to know what to do when you get to your exit ticket. Is 3 less than my divisor?
Yes.
So I can bring down my 7. Okay, I guess Sadie wants to answer. Sadie, what multiple of 4 is closest to 37 without going over?
36.
36. 4 times what equals 36? Blair?
9.
9. 7 minus 6? 1. Now I don't want a remainder.
So you drag a 0.
So I'm going to drag a 0 down. Probably on Zern, you get to drag things around, don't you? I'm going to drop it down there.
Drop it like it's hot.
Yeah. So, which multiple of 4, Fernando, is closest to 10 without going over? 8. 4 times what equals 8?
2.
10 minus 8 equals?
2.
You getting this?
Yeah.
Okay. Now what do I do? Because I don't want a remainder, Halen. What I need to do another time.
You drop another 0 down.
He couldn't let you answer, Halen. Blair said drop another 0 down. Is he right?
Yes.
All right.
Then I'll make it 20.
Do we have a multiple of 4?
Yes.
And you can just keep writing right into your next problem if you wrote too big. Okay, what multiple of 4, class?
20.
20. 4 times what equals 20?
5.
So my answer to the problem, who can say that number? 1 and 925,000. Okay, we've got one more. And then we'll be ready for practicing on the problem set. Okay, are you ready? 84 divided by 4, I want you to solve this problem by yourself. Compare your answer with your neighbor. Okay, what'd you come up with? Daniel. Did you and your neighbor have the same answer on that? Did you compare?
Yeah.
Okay. Did you think the standard algorithm was necessary, Maite?
No.
Why not?
Because it was easy.
Well, I need more information than it was just easy. Huh? It was obvious? Okay. What do you think she means by it was obvious? Channing?
Well, because one of the easiest things in 4 is the actual 4 in the end. So you just do 4 divided by 8 and 4 divided by 4.
Well, 8 divided by 4. So Channing did this. She did in her head, and I bet a bunch of you did this. You did 8 divided by 4 equals 2. And then you did 4 divided by 4 equals 1. So what did you get for your answer? 21. I'm almost thinking unit form would be much easier than standard algorithm on this one. 84 ones divided by 4. Now, who said it was obvious? My take? Here's what she meant in mathematician's words. Both numbers are divisible by 4. So there's no reason to write the standard algorithm because I don't have to regroup anything. Okay? So when she said it's obvious, I love the way she said that. But what it means is they both divide evenly by 4. You don't have any remainders. You don't have to regroup, and life is simple. Okay?